Okay, everyone, welcome back. I know it's been, a whole week and a half since you even heard my lovely voice. But here it is, ta-da, and we're back with another lesson. So we still got to continue with school. We still got to learn some stuff. I hope you guys did. I hope you, on your midterm and your quiz, you guys were able to figure out exactly what you may have done incorrectly so that you can do a little bit better next time. But if not, please contact me because I can actually explain this to you. Okay, and that really goes for everything. If you don't understand where you went wrong on any of this, please ask me so that I can help you. Okay, anyway, back with another lesson. Here we go. All right. So in this one, we're going to learn about percentiles. We're going to learn about quartiles. We're going to figure out how to work with quartiles, and then we're also going to learn how to make a box and whisker plot. And I put that lovely picture of a I'm really bad with animals. I don't know, a seal or sea lion, I'm not sure, maybe it's an otter, but it's very cute. And look at those whiskers. All right, so we're not going to learn about animal whiskers, but we are going to learn about a box and whisker plot. Okay, so first of all, what are percentiles even? Okay, percentiles will be dealt in numbers, of course, so this is going to be quantitative data. This is all numerical stuff that we're learning right now. Okay, so remember back in the, before you guys got to college, I'm sure everyone took the SAT, right? Those are standardized tests. I don't know if you guys actually took those like in elementary school and middle school and high school. Remember STAR testing? I don't know if you guys had to do it, but I know I had to do it when I was younger. It was every year, like in April, we would have to do these standardized tests, and they just wanted to see where we are, where like the third graders, if they're learning what they're supposed to learn according to the curriculum, and which school is doing better than what school, or what district is doing better. And I used to think that it had something to do with the funding that they would give us. So because the teachers really wanted us to score really well. But the thing is, it had nothing to do with our grades. It was just a standardized government test. So anyway, standardized tests. Remember back standardized tests. So sometimes, like after we would take our standardized tests, they would always send you your scores in the mail, okay? And I'm pretty sure you guys still get scores in the mail, or at least in your email, like with your SAT scores. And in your scores, they tell you what percentile you fall into. They might be like, oh, you fall into 90th percentile, or you fall into the 50th percentile, you fall into the 77th percentile, and that doesn't mean you scored 77% on the test, okay? That doesn't mean that 77 people or 77% of the kids who are taking the test are, better than you either. Okay, what that really means is that you did better than 77% of the people taking the test if you scored in the 77th percentile. So what that means would be like if you had a classroom of 100 students, okay, you guys all took the same test, and they said you scored in the 77th percentile. That means you did better than 77 of the students in that class. Okay, that would mean you're what? I think you're probably ranked number 33 in that class, I guess. So it would mean you did fairly well, basically. So basically what I'm trying to say is if you know you're going to take a standardized test, make sure you take it when all the not very smart kids are taking tests. That way you score better. Just kidding. That's impossible. You don't know who's actually taking your tests or anything like that. You have no way to calculate that. And for the most part, especially if they're nationwide, I'm pretty sure that the playing field is going to be even if they're comparing you to everyone in the nation. Okay, so anyway, aside from that, now you know what percentiles are. It means that you did better than, or you're above a certain percentage. Okay? All right, so percentile definition. Well, remember on the previous slide when I kind of told you guys what it meant when you said percentile or you said something falls within a certain percentile? So there are a couple rules that you need to know when dealing with percentiles. Okay, so percentiles, first of all, cannot, or they have to be between 1 and 99. Okay, you cannot say negative second percentile or negative 3 percentile, or nor can you even go higher than that, higher than 99. So you can't go, that was the 105th percentile, or you fall within the 300th percentile. That doesn't exist, okay? We can't do that. Nextly, whatever number you pick as your percentile, okay, that percent of values will always fall below that number. Okay, like when we were dealing in that previous example, like the 77th percentile, all of, if your percentage that you're looking at or your percentile that you're looking at is 77, that means all of the values, the percentage values will fall below that number. Okay. And then 100 minus the percentage of the values will fall above that number. I know it kind of sounds a little bit confusing, but so you're thinking all the values that you're considering with a certain percentage will fall below that certain percentile number. Okay, and then when you're thinking everything outside of that is like falling above or is better than or greater than. Okay, so anything that you're thinking of that's greater than, the way you figure that out is going 100 minus the percentage, and then you find all the values that fall above that number. We'll see this a little bit more further down. Okay, so anyway, an example, let's say 20 people take a test. Okay, and let's say there's a maximum score of 5 on this test. Okay, so only 5 points. The 25th percentile means 25% of those scores will fall below this score. Okay, will fall below a certain score, right? And 75% will fall above that score. Okay, so if you say 75 percentile, scored something on this test, that means 25% of the scores fell below that score. Okay, 25% of the people who took that test fell below a certain score. And 75% would be, like, remember up here we said 100 minus the percentile of values will fall above that number. So 100 minus 25 is 75%, right? So 75 will fall above that score. Okay, so let's say this is a really easy test and 12 people in the class got a 4, okay, which is like a B, and the remaining 8 people got a 5. Okay, so the 25th percentile, or the score cuts off the bottom 5 test scores, okay, will be 4. I mean, in this situation, actually, even the 50th percentile will still be 4. Okay, so but anyway, 25th percentile would mean 25% of that, 20 people taking the test will cut off the bottom 5 test scores. Okay, because 5% of 20 people will be 5. So the bottom 5 test scores would be 4. All right. I mean, even, of course, the 50th percentile would still be 4 since 12 people, or majority of the people who took the test got a 4, but that's besides the point. Anyway, so this would come out very differently, actually, if it were a more harder test and more people got a score that was like below 3, or maybe some people got a score of 1, some people got a score of 2. So of course those numbers would be a little bit different. All right, now let's look at quartiles. Yay, now after we already figured out what percentiles are, now we're gonna get into quartiles, and these are, it would be really cool if you can get yourself into thinking of quarters, you know? I know that's how I think of this kind of thing. That's just how I think in general. So if you're one of those kind of people, great. You're just like me, and this is gonna catch on so easy. So anyway, a quartile is just a specific set of percentiles, okay? And there are, well, 3 pretty much. They're technically 4, I guess, if you count the, 100, well, you don't really count the 100th. Yeah, so pretty much there are technically 3 that we will ever be working with. So anyway, 3 quartiles that we need to know. Okay, so think of quarters, all right? The first think of quarters in $1. All right, let's think of that. Okay, there are 4 quarters and 1 whole dollar, right? So the first quartile, or the first quarter, gives us 25 cents, or, haha, 25%. So it's got, the first quartile is just your 25 percentile. Okay, second quartile. That means we got 2 quarters. We got 50 cents. All right, so now you're in the 50th percentile. Okay, which, haha, I don't know if you guys remember, but the middle, okay, or the halfway point is your median. So that should sound a little bit familiar with you. Then we got the third quartile. So we got 3 quarters now. That's 75 cents. Or 75 percentile. All right, so that's our 75 percentile. So these different percentiles are so easy, and they're just, since we're already used to quarters and money rules everything, we all already kind of know quarters and quartiles, and it's just second nature to us, right? So these can all be calculated by hand, and we're going to learn how to do that. All right, so calculating or computing quartiles. Okay, so let's say you have a set of data. You got your data set. Okay, so what you're going to do is you go ahead and you order your data as what we usually do when we start calculating when we start working with our data sets, right? We always order it from the smallest to the largest, so that way we can figure out our measures of variation and central tendency. And now we're going to be looking at quartiles and percentiles. So always we order the data from smallest to largest. Then, haha, here it comes again. We're going to find the mean, or the median, my bad. We're going to find the median. Okay, and you guys all know how to do that because you're all professionals now. We find that middle number, or if it's, of course, an even numbered data set, then you also know how to figure out the median using that. Remember, you find the 2 middle numbers and then you add them and divide by 2. Remember that? I think you remember that. So anyway, you find your median, and voila, that is your second quartile, or you also call that your 50th percentile. Okay, so now, how do we find the next 2 quartiles? Well, you basically cut your data in half right there. You found your middle. So what we're going to do now is we're going to pretend that we broke the data up into 2 different sets. Okay, so now we're going to look at the top half, or like the lower half of the data, the smaller numbers to the median. Okay, and in that half of the data set, we're going to do the same thing. We find the median there. Okay, So go ahead and look for your median. Remember, if it's an odd number, it's literally just the middle number. And if it's an even, if you have an even number of data right there, then go ahead and take your two middle numbers, add them and divide by 2. Okay, that number is your first quartile. Okay, or your 25th percentile. Okay, and then now finally, to figure out what our third quartile is going to be, we're going to do the same thing with the second set of data. Remember when we split our data in half? So now we're going to look at the lower or the upper half of the data. All right, and do the exact same thing. Go ahead and find the median, and whenever you go ahead and do that, that is going to be your third quartile or your 75th percentile. All right. Now, now what's next is, remember a range? Remember how we did that? We like took the largest number and then subtracted the lowest number, and then that was our range. Well, we're gonna do a new kind of range. This is like upgraded range 2.0. Okay, this is called interquartile range. All right, so we have a new kind of range that we're going to start looking at, and all you're going to do here with the interquartile range is you're going to take your third quartile value and your first quartile value. Okay, so you're just going to minus your first from your third, and that's how you get your interquartile range. Okay, and just so you guys know, in the future, if you ever see IQR, that means interquartile range. And of course, all you have to do is take your third quartile and minus it, or minus your first quartile from that. Okay. So this is going to be a data set based on how many beds, because normally when we determine whether or not, or like what type of, how large a hospital actually is, we look at how many number of beds that they have. So we're going to say that, or these are all the number of beds that the different hospitals in Massachusetts that we looked at have. Okay, and we're gonna go ahead and use that as our data set and do some work on that. All right, so this is the first step in, figuring out the whole quartile situation. So what we did was we ordered all of our data from smallest to largest right here. Okay, so we went smallest beds all the way to the largest beds. Okay, so there's your first step. Order your data. Very important. All right, so now let's go ahead and go through the steps and figure out what our quartiles are. The first one, or the first step in figuring out what our quartiles are, is we jump straight to the second quartile. We don't go to the first, we figure out the second quartile. Okay, I know it's funny, but we do that. All right, go to the second quartile, and how we're going to do that is we find the median. Luckily, in this data set, it is an odd number of data. Okay, so we just have to find the middle number, and that is going to be our median, which is going to be our second quartile or 50th percentile. Okay, and so that number is 126. All right, that is our 50th percentile slash, second quartile. Okay. All right, so next step. Now we're gonna figure out what our first quartile is, or 25th percentile. So how do we do that? Well, okay, we already figured out what our median was. Okay, so this, we're not gonna use this number anymore. If you really want to, you can kind of cross that out. Because we're going to ignore that. We already used that. We figured out that is our second quartile. Okay, so now to find the first quartile, we're gonna look at the smaller half of our data set, our first half, which is this group of numbers. Okay, and now we got to find the median of that group of numbers, which is 90. Okay, so 90 is going to be our first quartile or 25th percentile. Okay, next we are going to find our third quartile or 75th percentile. So like I said before, we already used this guy. We don't have to worry about that one. That's our 50th percentile. This is our 25th percentile. If it helps to kind of cross out the median, just so that you don't get confused and you accidentally include it in your numbers when you're trying to find the first or third quartile, you can go ahead and just cross that off. You do what you got to do, or you don't have to. But anyway, you're not going to use it to find the other quartiles. So anyway, now we're going to pay attention to this, data, these numbers, and we're going to figure out what our median is there, which is 254. Now that is going to be our third quartile or 75th percentile. Okay, so there we go. Now we figured out all three of our quartiles. Now the next step was for us to figure out what our new IQR is. Okay, and remember how we figured out our IQR? We take our third quartile minus our first quartile. So in this case, it's going to be 254 minus 90, which gives us 164. Okay, so there are some extra things that you need to know to, be careful of when you start doing problems like this. Okay, and the reason is because I know on the example that I showed you, it was just nice and clean. We had a good amount of values, and it was just like we had odd numbers like on both sides and every which way, so we never really had to, take an average to find a median and do anything weird or complicated. Okay, so that was nice, but the thing is, it's not always going to be that nice, and sometimes when you have to find your medians or for your quartiles, you are going to have to do a little bit of, averaging. Okay, and so I don't want to get you guys confused or anything like that, but let me show you what's going to happen when you have other types of or other amounts of values. Okay, so in this example, we have 6 values. That's obviously an even number of values, right? So when you're finding your second quartile, your Q2, the first step when we look for the median in that whole data set to find our Q2, of course, as usual, because you all know how to do medians now, we're going to have to take an average of this whole middle number, right? Yeah, we take the average, and that is how we're going to find the median from there. Okay, and I mean, it's not just that simple, because what we're going to do after you've already figured out what that number is, I didn't calculate it, so just pretend that this is that number. Then it's time for you to now go ahead and look for your Q1 and your Q3, your quartile 1 and your quartile 3. Okay, so great. Now let's go ahead and look at that. Well, remember in the first one when I told you that, we had a nice clean odd number of data set right there, and that median did not get to double dip. Like, we got to cross out that median number, and it was not going to be used again when you're looking for your Q1 or your Q3. However, when you have 6 even numbers of values and you had to find an average for your median, like in this problem, you're definitely going to be double dipping your numbers. Okay, so your Q2 was like a middle, a median or a middle number in between this. Well, when you go in and you go ahead and look for your Q1, you're going to be reusing this 90. Okay, you're not crossing it out. You have to use it. So then you're going to find your median from this set. And of course, this is easy because this is technically an odd number of numbers. So your median is going to be 74 in this case. And then you're going to go ahead and find your Q3. So you're going to take the other half of your data set. And since you had an even number of values, and you had to take an average, you know, between these two middle numbers to find your median or your Q2 here, like I said, you're going to be reusing that number. You're going to be reusing this middle number in your set. And it only happens when you have like even numbers. That's when you definitely reuse your data when you're looking for your next set of medians or your quartile 3s or your quartile 1s. Okay, that's the only time you actually do. But you really have to just sort of be careful and judge the data as you go. You can't just blindly follow steps. So you definitely want to follow these steps carefully and pay attention to what your numbers are doing and how many numbers you have in each situation. So in this situation, the numbers we have left to look for Q3 are just, you know, this nice simple set of 3 numbers, which is an odd number. So of course, this 121 would be our median here. That's not too bad. Okay, so that would be our Q3, that would be our Q1, and whatever we figured out after we did the math here would be our Q2. Okay, so let's look at another one. Okay, so what if we have 7 values instead of 6 values in our data set? Okay, let's look at this. So this is an odd number of values. Great. You know what that means? That means that the first number, or you know, the very middle number, which is 97 in this case, is definitely the median, and you are not going to be using this number again. So, you know, when it's a definite number like this and you didn't have to do an average to find your median, that is when you can go ahead and cross this off because you are definitely not using it again. And yes, this is your Q2. So now let's go ahead and look at our figure out what Q1 is. Okay, and Q1, we're going to go ahead and look at this data set, okay, or this half of the data. We're not reusing 97, so it's pretty easy. We just find the middle number in this case, which is 74. That is going to be our Q1. Okay, now let's look for our Q3. We got this data set right here, and the middle number is our median here is the 126, so that is going to be our Q3. Great, we figured it out. And like I said, when the median, of the data set, when your Q2 is just like a straight number, you didn't have to take an average of 2 different numbers to find your median right there. That is when you don't have to reuse it. So you can go ahead and cross this off when you're done with it, and then you can work your way through the other sides. Okay, but like I said, if you have 2 numbers that you had to figure out your median or your Q2 with, then that is when you will be reusing those numbers for your data sets, like in the previous example. Okay, let's look at another one real quick. Okay, so now we have 8 values instead of 7. Okay, so how are we going to find what our Q2 is? Right, we take the median after we've already ordered everything from smallest to biggest, okay, in our data set. Then we find that we're definitely going to be using these 2 numbers to find an average. Okay, so whatever that is. Sorry, I didn't calculate it. So pretend that this is whatever number that comes out to be. Okay, then you got to go ahead and find your Q1 and your Q3. Well, since we had to take an average for our Q2, we are definitely going to be reusing these 2 numbers. Okay, so if we go ahead and look for our Q1, we have to use this number, this 97. So our Q1 is going to come from this data set. Okay, now let's figure out what our median is here. Oh my gosh, look. We have to find another average. Okay, so our Q1 is going to come from another average. All right, so our Q1 is, we're going to add these 2 up and divide by 2, and that is going to be our Q1, whatever that is. Okay, I didn't calculate these, sorry. This is just hypothetical. Anyway, so now let's go ahead and look at the other data, and we'll try to find our Q3. So what part of the data do we have to use for our Q3? We're using all of this. We have to reuse the 121, and the rest of the data, or the second half of the data. Okay, now let's figure out what Q3 is. We have to find the median here. And oh, haha, we have to take another average because this is an even number of data. Okay, so the median is going to be whatever it is when you add 126 plus 142 and divide by 2. And pretend it's right here. Okay, so that is how it would work when you have 8 values. Okay, or really all you're going to be doing when you're looking for your Q1s, your Q2s, and Q3s, just follow those steps. And every time you look for your medians, if it is an even number, those are the rules. Okay, you have to do a little bit of extra work. Like I said, if there's an even number where you had to take an average to find your median, then you're definitely going to be reusing that number. That number gets to double dip in the next data set to find the next Q, the next quartile. Same thing with over here. This number definitely gets to double dip and be part of this data set when you're looking for your Q3. And it's just because we found an average for the median over here instead of just having a direct number as we would if we had an odd number of data in our data set. Okay? So I hope that you guys kind of understand. I hope that wasn't too confusing. Okay, so last example, I promise, and then we'll get on to the box and whiskers. Okay, so what if we had 9 values in our data set instead of 8 values? Well, okay, let's look for what our median is. It's definitely going to be one number because for our Q2, because the median is just the actual middle number, so it's that one, right? Now we're gonna look at our Q1. How do we figure that out? What do we include in our data set? Well, we definitely don't include this, okay, because we didn't have to find an average in this one. Okay, so we don't have to include that in our when we look for our Q1. Our Q1 is going to come from the rest of the first half of the data, excluding this. Okay, so looks like we are going to be taking an average, okay, because we have even numbers of data on this side. So we'll have to take an average. We're going to add 74 plus 90 and then divide by 2 and get whatever we get, and that is going to be our quartile 1. Next, we're going to look for our Q3, okay, and what values are we using for Q3? Well, we're going to use these last 4 values for our Q3, or to find Q3, because we don't have to use this. Since we didn't take an average, okay, to find our Q2, we're done with this value right here. We don't have to use it to find our Q3. This guy does not get to double dip. That's the rule. So anyway, how do we find our Q3? Well, we have our data set right here, okay, that we're gonna use. And the middle number looks like the median's going to require us to take an average, just like how we did over here. So how we're going to find the Q3 in this situation is we're going to add 142 plus 155 and divide by 2. Okay, and we'll get whatever we get. And that'll be Q3. Okay. Okay, so the moment you've all been waiting for, what the heck is a box and whisker plot, and how in the world do we do it? Okay, so let's just use the initial data from the beginning of this lesson, okay? This data right here. And pretend not pretend, we actually did. We numbered them in order, okay? So now let's just gather all of our box plot ingredients, and then we'll be able to create like a beautiful box plot in a couple slides down, okay? So what we gathered from the previous slides, because this is all leading up to the box and whisker plot, okay? Everything we did with the quartiles and all that, this is the grand finale. This is why we did it, okay? So we gather all of our ingredients. So we have our units, which is hospital beds. That's what this data means. These are hospital beds, okay? Then we have our minimum right? We know what our minimum is, the smallest number. Okay, and then we already calculated our quartiles. So our Q1 was 90, our Q2 was 126, our Q3 was 254, and our maximum number, which is this one, is 364. Okay, so you have all of your ingredients right there. Now let's make a plot. Okay, so the first step to making this plot is to draw a line. All right. And then go ahead and just kind of look at the type of data that you have and the numbers, and we'll figure out what scale we want to draw this at. Generally in box and whisker plots, you don't necessarily have to be as precise or as mathematically, especially when you're doing it by hand. It's not like we're doing a frequency table is what I'm trying to say. So we don't have to be exact. We don't have to do math to figure out what our classes are. We can draw this to scale. Okay, we can eyeball it, but of course with some precision, don't get crazy. Anyway, so what I did was I went, okay, our numbers are pretty much from 0, nothing, to all the way. Our highest one is 364. Which, I mean, if we want to round everything, if we want to use like 100 scale, then it would be cool to put 400 as the highest, and then we can go ahead and label everything in the hundreds, Okay, and then we'll measure everything according to that, or, draw our box plot to that scale, okay? So, I mean, if we had maybe what if our highest was like 1158? I would probably say then if our max was like 1158, I would probably say maybe we should still use hundreds, but maybe our max or our number up here would probably be like 1200. Okay, so that's what I'm trying to say. Or, if our highest number was like, if we didn't even get to the hundreds and our maximum was like 57, maybe we would want to do tens. Okay, so maybe we would want to go 10, 20, 30, 40, all the way up to 60. Okay, so that's just, an example. Just keep in mind, make your scales reasonable. Okay. So anyway, just by looking at your data, make them reasonable. Okay, make it appropriate to whatever your max is. You just want to be able to fit your max in there. So anyway, all right. Next. Okay, so what we're going to do now is we're going to go ahead and start plotting everything. Okay, so our first one that we're going to go ahead and plot is you're going to take your Q1. All right, find your Q1, which was 90, and let's go ahead and draw a line, which is what I did here. Okay, we drew that first line right there. And so what is your line supposed to look like? Is there some sort of rule for how this is? No, just be, make it decent. Like it needs to be visible. It doesn't have to be super fat, but it doesn't need to be too small either, because you need to be able to understand that it's there. Okay. So anyway, then we're going to look for our Q3. All right, so here's our Q3, and we're going to go ahead and put our Q3 up, which is right there. Okay. Next, you're going to go ahead and connect your Q3 and your Q1. So I just went ahead and drew that box right there to connect our Q3 and our Q1. And then we're going to take your Q2, okay, and our Q2 is going to go right there. So we went ahead and put our Q2 right there. That's our median. Okay, so we went ahead and we put all of our different quartiles on here. Remember, this was Q1, this is Q2, and this one is Q3. Okay? All right, so now what do we do with our minimums and our maximums? What we're going to do is we're going to put them on the graph like this. We're going to make them smaller little horizontal lines. So we'll take our max, and our max is probably about right there. Make it a smaller line than your actual lines for your quartiles though. You want them to be smaller. So then take our minimum, 41, and go ahead and put it right there. And then what you're gonna do is we're gonna go ahead and connect them. So we connected them here, right? That was connected. All right, and then go ahead and label your IQR, your interquartile range, which was 164. Remember that we calculated that in like several slides ago. So that's what this is. Okay, this whole area, that is what our IQR is. Okay. All right. So why do we even do box and whisker plots? Well, it's kind of the same answer for a lot of these, you know, a lot of the other different plotting that we have learned in this course, okay? Like with our histograms and then with our stem and leaf, we do this because we want to see the distribution in the data. So this is just another way to look at distribution, okay? So you can kind of see the spread of the data, we can look at the distribution, and here is just sort of a scale that you can refer back to see whether you have skewed right distribution, skewed left, if you have normal distribution or normal, like a smaller normal. Okay, so you notice how, remember normal is like even. Notice how these are both even. Okay, these are both even distributions. So we got normal distribution and we got skewed right and skewed left. So go ahead and take your time, study those. Of course, you can always refer back to this when you're doing your work. Okay, and I hope you guys understand what's going on here. And if anyone has any questions, please leave them in the comment section or go ahead and shoot me an email and I will be happy to help you out. Okay, look forward to the next lesson. Hey.